Hello everyone, welcome to maths classes. Let's solve some problems on arithmetic progression. Finding first term and common difference when sum of n terms or nth term is known in an arithmetic progression. Questions 10, 11 in exercise 5.3 chapter arithmetic progressions. Question is, show that a1, a2 and so on an form an arithmetic progression where an is defined as below. An is equal to 3 plus 4n. They have given an, that is nth term. We should show that a1, a2 and so on an form an arithmetic progression. This is one part of the question. They have also asked to find the sum of first 15 terms in each case. We should find the sum of first 15 terms. Let's solve the problem. They have given an is equal to 3 plus 4n. Okay. We know the nth term. If we assume n is equal to 1, then you get a1 is equal to, just substitute n is equal to 1 in this first equation. a1 is equal to 3 plus 4 into 1. So, 3 plus 4 is 7. We got the first term. Similarly, if n is equal to 2, you get a2 is equal to 3 plus 4 into 2. So, 3 plus 8. 8 plus 3 is 11. Similarly, if n is equal to 3, a3 is what? 3 plus, here you have 3 plus 4 and so substitute the value of n here. 3 plus 4 into 3. So 3 plus 12. We get 15. Now we got an arithmetic progression. We should check whether this is arithmetic progression or not. First term is what? 7. Second term is 11. Third term is 15 and so on. So to tell whether the given series is an arithmetic progression or not, what should you find? Difference between the terms. Difference D is what? We should find difference between consecutive terms. This is first term, this is second term. A2 minus A1. A2 minus A1 is what? 11 minus 7. You get 4. Now consider these two terms. A3 minus A2. 15 minus 11. You got 4 again. So, common difference. We got common difference. That is, difference between the consecutive terms is same. Difference is same between consecutive terms. So, A1 you can tell. So, A1, A2 and so on an form an arithmetic progression. So one part of the question is solved. We have showed that A1, A2 and so on an form an arithmetic progression. Now second part of the question. They have asked to find the sum of the 15 terms. So what is the formula? Sn is equal to n by 2 into 2a plus n minus 1 into d. Here they have given sum of 15 terms. So n will be 15. Now substituting, you get S15. That is sum of 15 terms is equal to 15 by 2 into 2a. A is the first term. We got A as 7. We got 7 here first term. Plus n minus 1. So 15 minus 1 into d is what? Common difference. We got d as 4. So, you get 15 by 2 into 2 7s are 14. 15 minus 1 is 14. 14 into 4. So, 15 by 2 into 14 plus 14 into 4 is 56. So, 15 by 2 into 56 plus 14 you get 70. 2 ones are 2 35s. So you get 15 into 30. 15 3s are 45. 450 plus 75. So we get 525. So sum of the 15 terms of the arithmetic progression is 525. Now here we found common difference by finding A1, A2, A3 and so on. By finding first A1, first term, second term, third term. Then we found common difference. This is one way. There is another way to find the common difference in the first term. Let's see. They have given an is equal to 3 plus 4n. Based on this, we can find the first term and common difference. Let's see how we can do that. So it is given that an is equal to 3 plus 4n. Problem is actually finished. There is another way to find the first term and common difference. Let's see. We have the formula is what? For the formula for nth term, an is equal to a plus n minus 1 into d. So you should have n minus 1 into d. Here you have 4n. So you should write in this way, n minus 1 into d. How can we do that? Let's see. So you can write 3 plus, here n minus 1 into d is nothing but what? Nd minus d. That means n is multiplied with some number and subtracted by the same number. So here n is multiplied with 4. So again n into d. This is n, this is d. Again what? Here minus d. So do minus 4 plus 4. Minus 4 plus 4 is nothing but 0. So 3 plus 4n minus 4 plus 4. Now you should be in the form of what? N minus 1 into d. So in these two terms, take 4 as common. You get 4 into n minus 1 plus 4. This 4 as it is. 3 plus 4 is what? 7 plus 4 into n minus 1. If we rearrange again, you get 7 plus n minus 1 into 4. Now you compare with the general form. General form of nth term is what? An is equal to a plus n minus 1 into d. So when you compare these two, we get the value of a as 7 and the value of common difference d as 4. In this way also you can find the first term and common difference just by considering the given value of nth term. Next question. Show that a1, a2 and so on an form an arithmetic progression where an is defined as follows. So they have given an is equal to 9 minus 5n. Also find the sum of first 15 terms in each case. Let's do that. They have given an is equal to 9 plus 5n. So this is first equation. If n is equal to 1, we get, by substituting n is equal to 1 in the first equation, we get a1 is equal to 9 minus 5 into 1. So a1 is equal to 9 minus 5, that is 4. This is the first term a1. Now if n is equal to 2, you get a2 is equal to, that is substitute 2 in the first equation, 9 minus 5 into 2. So 9 minus 10, we get a2 as minus 1. And now if n is equal to 3, substitute n is equal to 3 in the first equation, we get a3 is equal to 9 minus 5 into 3. So 9 minus 15, we get minus 6. Now we got the values of a1, a2, a3 and so on. Let's check if this forms an arithmetic progression or not. So first term is 4. Second term is minus 1, third term is minus 6 and so on. To check if it is in arithmetic progression or not, let's find difference between consecutive terms. First, difference between a2 and a1. a2 minus a1 is what? Minus 1 minus 4. We get minus 5. Now find the difference between a3 and a2. a3 minus a2. We get minus 6 minus of minus 1. So minus 6 plus 1. We got minus 5. So difference is same in both cases. difference D between consecutive terms is same. So we can tell A1, A2, A3 and so on AN form an arithmetic progression. We can tell this. Now they are asking to find sum of 15 term. Let's do that. What is the formula? Sn is equal to n by 2 into 2a plus n minus 1 into d. We need sum of 15 terms, so the value of n will be 15. 15 is equal to 15 by 2 into 2a is what? First term of the arithmetic progression. 2 into 4 plus 15 minus 1 into common difference is minus 5. So we get 15 by 2 into 2 fours are 8 plus 15 minus 1 is 14 into minus 5. So 15 by 2 into 8 plus 14 5 is 70. Plus into minus is minus. So 8 minus 70. So 15 by 2 into 8 minus 70 is minus 62. So 2 ones are 2 31. So you get 15 into minus 31. So you get 15 into 30 is 450. 450 plus 15, 465 minus 465. So sum of the 15 terms of the arithmetic progression is minus 465. They have given an is equal to 9 minus 5n. So, what is another way to find first term and common difference directly from nth term? Let's see. We know the formula what? An is equal to a plus n minus 1 into d. So, a plus nd minus d. So, we have plus nd minus d. So here we should write here plus nd, that means plus n into minus 5. So it is in the form of nd. We need minus d. D means here what number you have? Same number. So minus 5. That means we are adding plus 5. Now subtract. Here minus into minus, it is plus 5. Here it is minus 5. 5 minus 5 is 0. So we are adding minus 5, we are subtracting minus 5. Answer you get 0. So there is no issue. We can do this. So next you can do what? 9 here. Next step is take common difference d. Now here common difference is what? Minus 5. Take it as common. So you are left with n here. In these two terms, take minus 5 common. You will have n minus 1 plus this term is left. Now this term is left, right as it is. Now 9 plus into minus is minus. 9 minus 5 is 4. So you get plus minus 5 into n minus 1. If we rearrange, you get 4 plus n minus 1 into minus 5. Now compare with the general form. An is equal to a plus n minus 1 into d. We get the values as a is 4, d is minus 5. We got first term as 4, common difference as minus 5. In this way directly we can find first term and common difference. If we know the first term, we can automatically find second term, third term and so on. We can also find some of the n terms if we know first term and common difference. Next question. If the sum of first n terms of an arithmetic progression is 4n minus n square, what is the first term? What is the sum of first two terms? What is the second term? Similarly, find third, 10th and nth terms. So, they have given sum of first n terms, but we know the formula. Sum of n terms is what? N by 2 into 2a plus n minus 1 into d. We know this. They have given sum of first n terms as Sn is equal to 4n minus n square. In the last problem, what did we do? If n is equal to 1. This is first equation. Substitute n is equal to 1 in the first equation. That is sum of one term. Sum of one term means only the first term. 4 into 1 minus 1 square. 4 ones are 4 minus 1. 3. S1 is 3. S1 means what? Sum of, see, you have only one term. Only one term. Sum of the one terms means that will be first term itself. So, this is nothing but first term. A is equal to 3. We got first term of the arithmetic progression. A is equal to 3. Now, if n is equal to 2, why are we finding second term, third term? We need to find common difference. That's why we are finding. S2 is what? 4 into 2 minus 2 square. Substitute value of n as 2 in first equation. 4 into 2 is 8. 2 square is 4. S2 is 4. S2 means what? Sum of first term and second term. A1 plus A2 is equal to 4. We already got first term as 3. A1 or A is 3. So, substitute that value here. 3 plus A2 is equal to 4. That means A2 is equal to 4 minus 3. So, we got second term as 1. A2 is equal to 1. Now, here they are asking to find sum of first two terms. We know the first term, we know the second term. So, A1 plus A2 is what? 3 plus 1, that is 4. This is sum of first two terms. Without using the formula, we know the first and second term. So, directly you can find S2. 3 plus 1, 4. We got the answer. This answer is all. They are asking what is the second term. We got the second term also. Second term A2 is 1. Similarly, find the third term, 10th term and nth term. Now, we know this is an arithmetic progression. So, what is common difference? Common difference is A2 minus A1. So, 1 minus A1 is 3. 1 minus 3, it is minus 2. We got the common difference also here. We have the common difference. We have the value of first term. We can find third term, 10th term, nth term and so on. Let's see that. Now, we need third term. So, we have the formula an is equal to a plus n minus 1 into d. We can use this formula and find. Let's do that. A3 is equal to a plus 3 minus 1 into d. We know the value of a as 3. Here you have first term as 3. 3 plus 3 minus 1 is 2. Common difference is minus 2. So, 3 plus into minus is minus 4. So, 3 minus 4 is minus 1. So, we got the third term as minus 1. Now, they are asking 10th term. So, A10 is equal to A plus n minus 1 means you are using 10th term. You are finding 10th term. So, n is equal to 10. Next, A is 3. 10 minus 1 is 9. Common difference D is minus 2. So, 3 minus 18. So, we get minus 15. This is 10th term. Now, they are asking nth term. Nth term means what? An plus A. Now, let's find nth term also. An is equal to A plus n minus 1 into d. This is the formula. Nth term A is 3 plus n minus 1 into d is what? Minus 2. If we solve, we get 3. Plus into minus is minus 2n. Minus into minus is plus 2. So, we get 5 minus 2n. This is nth term. 5 minus 2n. We are able to find third term, 10th term, nth term. We are able to find second term. We are able to find some of the first two terms. Thank you for watching the video. Like, share and subscribe.